Hello guys, I want to analyze a beam shown on the board. So this is an equation. It's question number 2B, and the question carries 12 marks. So the question reads, draw the shear force and bending moment diagrams for the beam shown below and indicate all critical points. So the first thing to do, as usual, is to extend this line to give you space to draw shear force and bending moment diagram, and make sure you are doing it on one page. So like that. After doing so, the next thing to do is to start calculating the reaction at support. As you can see, we have support A and support B. So support A is a hinge support and support B is a roller. And this beam is subjected to clockwise and clockwise moment of magnitude 10 kilonewton meter. And also it has a point load or a concentrated load of 20 kilonewton. So we will use the three equations of equilibrium to determine its reactions. So we know that summation of moment about a point is equal to 0. So let's take A as our point. Solution. Summation of moment at A should be equal to 0. After doing so, now we will be calculating the reaction at D. So, in which direction is reaction D moving in reference to point A? So this is D. As you can see, the movement of my teaching aid. So reaction D is moving in anti-clockwise direction like this. So that is anti-clockwise direction. So it will be minus RD times the distance from where you are summing your moment from. So this is A. We have 3 plus 3 plus 3. So that is 9 times 9, like that. And then we have this moment, which is 10 kilonewton. So this moment will be taken into account when calculating reaction. So if the moment is moving in anti-clockwise direction, it will be a negative. And if it's moving in clockwise direction, it will be positive. As you can see, ours is moving in clockwise direction, so plus 10. Again, we have a point load of 20 kilonewton, or a concentrated load. In which direction is this a loading moving in reference to point A? So like this, clockwise. So plus 20 times the distance from A to C. 3 plus 3, that is 6. Is there any other loading? No. You equate it to 0. So something to note about the moment under the force, which is loading. So when you are calculating the reaction, you will take the moment the way it is. no multiplying a moment by distance because it's already a moment. And a UDL or a concentrated load is not a moment. So you'll have to change it to a moment, which is force times perpendicular distance. So it's equal to 0. So we can now open the bracket, minus 9 RB plus 10 plus 20 times 6 is 120, should give you 0. So minus 9 RB plus 130 should give you 0. So when negative 9 crosses to the other side, changes sign from negative to positive. So 9 RB should give you 130. You divide both sides by 9, which imply RB equals to, check your calculator, so that is 14.44 kilonewton. That is 14.44 kilonewton. After that, the next thing to do is to calculate reaction at A. And to calculate reaction at A, we will sum moment about a point, which is D. So summation of moment at D should give you 0. Again, reaction at A is moving in which direction? In reference to point D. So it's here. So it's moving this way, clockwise. So it will be RA times the distance from A to D, 3 plus 3 plus 3. That is 9. Okay? And then we come to this 10 kilonewton meter, which is a moment. So this moment is moving in which direction? In reference to point D. As you can see, like this. So that is clockwise. So it's plus 10. And then we have a point load of 20 kilonewton. So 20 kilonewton is moving in anti-clockwise direction. So it will be minus 20 times 3. No any other force, we equate it to 0. Then we have 9 RA plus 10 minus 60 should give you 0. So 9 RA minus 50 should give you 0. So when negative 50 crosses to the other side, it changes sign. So 9 RA should give you 50 over 9 over 9, which imply RA is equals to, so take your calculator, 50 you divide 9, that is 5.56. 5.56 kilonewton. Now, let's prove and see if our action are correct. And how are we going to do this? So, we will say summation of upward forces should be equal to summation of downward forces. The upward forces are the reactions. Reactions A plus reaction at D should give you the total downward force is 20 kilonewton. So it's 20. So we have RA RA as 5.56 plus RB 14.44 should give you 20. So 20 kilonewton is equal to 20 kilonewton. So our reaction are very, very correct. So the next thing to do is now to draw the shear force diagram. And how do you draw the shear force diagram? So first, draw the baseline. Since my pen are not writing, so draw the baseline. Like that. And name it shear force diagram. So above, the baseline is positive. Below is negative. So we start with reaction at A. Reaction at A is 5.56. We approximate like here and say 5.56. Five. 5.56. Then 5.56 will maintain constant up to the next loading, which is 20 kilonewton. A point to note, when you are drawing a shear force diagram, we only use reaction and forces, not this moment. So don't make a mistake of take 5.56, 5.56 minus 20. That is negative 14.44. So negative 14.44, somewhere like there, it will be constant up to there. So this is 14.44. Then negative 14.44 plus reaction at D, which is 14.44 is 0. So it brings you back to 0. So this is plus and this is minus. So by doing so, you have now draw your shear force diagram. So the next thing to do is to calculate the bending moment. So bending moment. So bending moment at A, bending moment at A is equal to bending moment at D. So bending moment at A is equal to bending moment at B and is equal to 0. Why? Because this is a pinned support and this is a roller support. So the bending moment at this support and that support is always equal to 0. Again, so we start calculating the bending moment at other points. So bending moment at B. Bending moment at B will be the area of this shape. It's a rectangle. So it will be length times width. So 5.56 from here to here. And then from here to here, that is 3. So times 3. So this one will give you 5.56 times 3. That is 16.68. 16.68 kilonewton meter. Then at the same point, so bending moment again at B. Here we'll have two bending moments. Why? Because this moment subjected to the beam, it will affect this moment. So if it's moving in clockwise direction, so you will add this one to this. So it will be 16.68 plus 10. So that one will give you 26.68 kilonewton meter. Bending moment at C, it will be bending moment at B plus the area of this shape. So that is 3 times 5.56. So this one will be 26.68 plus 16.68. So this one will give you 43.36 kilonewton meter. To prove our bending moment at B is equal to 0. To prove our bending moment at B is equal to 0, you can say that bending moment at B will be bending moment at C minus this. That will be 14.44 times 3. So this one will be 43.36 minus minus 43.32. So this one will give you 0 kilonewton meter. So after doing so, now we can comfortably draw our bending moment diagram. So let's approximate. So this is the BMD. So at A is 0, at B is 16. So at B is 16. Let's approximate. So this is 16. So this one will be a diagonal line like that. So this one done. And then the bending moment at B again will be 26.68. So we'll again approximate where 26.68 is. So somewhere, let's say like there. 26.68. Done. Then bending moment at C. At C, we have 43.36. So let's say somewhere like there. So that is 43.36. And then at D is 0. So you go back to 0. So this is plus. And our question ends there.